We are learning new methods of integration. There are some integrals that we still don't know how to solve them. Today we will learn how to do that in some special cases. We will start by solving certain integrals that you are supposed to know how to do it. Pause the video and when you are ready, play it again to see the answers of this. If you are ready, these will be the answers. In all these integrals, we use a simple substitution because the expression inside the brackets in this case was 3x plus 5. Here, the expression, the composite function inside e to the x was just 3x. Here, the function inside sine was 2 minus 3x. And here, as we can see, the expression inside the logarithm is 1 minus 4x. In all those cases, we could work with a simple rule by dividing by the constant that is being multiplied by x in every case. But there are other expressions like this one here when we cannot apply the rule as before because here this is not just a constant there. Here x is not a constant, and here the derivative of this is not just a constant. So we will use substitution method to solve these situations. Let's see how we do this. The first thing we will try to do is to simplify this expression. That's why we use substitution method. The expression that it is the argument here of cosine x squared plus 2, we will call it u. And now we are going to try to write this integral in terms of u instead of in terms of x as it is here. So we have this situation, but still x is appearing here. So what we are going to do is try to write this in terms of u. So we are going to find the derivative of u here in this side. Derivative of u will be 2x plus 0, correct? So we can find du here by multiplying by dx both sides. And we can find x dx by doing du divided by 2. If you see the integral that we have here, we had already cosine u, and we had x and multiplied by dx here, which was in terms of x. So if we can now replace x dx by du divided by 2. By doing so into the integral, what we get is an expression that does not depend on x anymore. It is in terms of u. And is also a very simple expression that we know how to integrate it. So to simplify this, we can take the 1/2 that is divided there outside the integral, and now you know how to solve this integral for u. The integral of cosine u will be just minus sine of u. Sorry, the integral of cosine u will be just sine of u and multiplied by 1/2 and plus the constant of integration. So we solved the integral but in terms of u so far. Our next step will be to go back to x. So we knew u was x squared plus 2, so sine u will be sine of x squared plus 2. So we can say now that the integral of this expression is the sine of x squared plus 2. What you can see here is that if you do the derivative of x squared here, it will be 2x. This x was part of that derivative, but it wasn't with the 2, so that's why we get the 1/2. So it makes sense to think that this integral, by using the change of variable u, what we achieved was a simpler expression that allows us to apply the integration. In this way, we could do the integration without making any mistakes. We are going to see some other examples. Let's suppose you have this integral to be solved now. As we can see, we have an exponential function, which inside the exponential function we have the function x squared, and then this being multiplied by x. So it makes sense here that the function inside is our substitute. We are going to use u as x squared. So the inner function here will be our new variable u. So starting there, we should find the derivative of u, which is with respect to x, and that will be 2x. Now, making du the subject, we know that this is 2x dx, and x dx appears here in the integral, so that will be du divided by 2. So going back to this integral, we are going to replace x dx by du divided by 2 and e to the x squared by e to the u. So now what we have in here is an expression all in terms of u. We can rearrange these, take out the 1/2 outside the integral to see it clearly, and we can see that the integral, we have just 1/2 the integral of e to the u du. So we know how to solve that integral because it's straightforward, e to the u. 1/2 e to the u plus c. And going back to our substitution, u is x squared, so replacing u by x squared, we get the integral of this expression. And that's the final answer. Okay, let's try new example. With trigonometric functions. In this situation, we are going to select one of the two expressions as u. We can select the cosine or the sine. In this case, we are going to do sine of 5x as u. You will see that there are some integrals with the choice is the same, but in others it could be easier one way or the other. So this we can achieve this idea of how do we decide by just practicing. So we choose u equals sine of 5x. So let's do the derivative of u with respect to x, so that will be 5 cosine of 5x dx. Now let's see, 5 cosine 5x. Cosine 5x dx is in here inside my integral, so it makes sense that I make that the subject, and it will be du divided by 5. So now going back to my integral, I can replace the sine of 5x by u and the cosine 5x dx by du divided by 5. So this is a very, very simple integral. I can take the 1/5 outside the integral and solve it, and it will be this expression 1/10, because u is u squared divided 2. So 1/10 of u squared plus c. A very, very simple integration. By transforming this into, changing this into another variable, the expression inside the integral is very simple. Well, now we know the only thing we have to do now is to replace u by sine of 5x. So this makes This expression is the integral of sine 5x cosine 5x dx. In the following examples, please take your time, pause the video, try to solve them by yourself, and then check that you are working correctly. This is the next integral, is the integral of 5x cubed over 1 plus 16x to the 4th. Choose wisely what will be your u. Try to see that you will need also the derivative of u. So choose which expression will be your u. Pause the video, solve it, and then check. Well, let's see. Well, obviously I will choose u as 1 plus 16x to the 4. Because when you do the derivative of something x to the 4, you know that x to the 3, which is here, will appear. So this makes sense. We cannot take this as u. It won't make sense. So having this as u, I will do the derivative. Du will be 64x cubed dx. Now I need, well, here I have 5x cubed. Okay, it's not that awful. So 5x cubed, the x cubed dx is du divided 64, and this will become 1 over, this 5 remains, and 5 over u. Okay, taking the constants outside, the 5 over 64 outside, what we get is a simple integral that we know how to solve, because the integral of this is just the natural log of u. And now we just need to replace u by its original value in terms of x, that was 1 plus 16x to the 4. Quite simple. Let's see another one and think what will be the u you will take here. Think about what's accompanying the e function, the exponential function. This is the inner function. The derivative of this will involve, say, minus 6x will involve x. So here you have an x which will be part of this derivative. So it makes sense that we make u this expression. Pause the video, and well, by doing that, by making u equals 5 minus 3x squared, we are going to find the derivative of u, which is minus 6x. So x dx will be derivative of u divided minus 6, because in here we have x and dx. The 9 is a constant, so we don't worry about that because we can always take it out of the integral. So here we have this by replacing x by dx by du over minus 6 and e to the 5 minus 3x squared as e to the u. Having done this, we can take out the constants outside the integral and just solve e to the u du, which is e to the u. Now we need just to replace by the expression in terms of x, and that's our integral. Well, next integral. Solve the integral by substitution. Pause the video, and when you are ready, you check the answer. Here is the answer. You couldn't do it on the board, so try to follow it. Okay, pause the video if you need. Let's go to another example. Be quite simple. Let's see another last example. Try this. Well, let's see the answer and check if you have it correct. Another example here. My suggestion here is write tangent as sine over cosine. here is the answer. So, summarizing what we have done so far. Select an integral